The biggest question of all. Have you ever gazed up at the stars and felt just how tiny you are? Our home galaxy, the Milky Way, is packed with hundreds of billions of stars, and that's just one among billions of galaxies scattered across the cosmos. But what if all of this, every star, every galaxy, was only a minuscule fragment inside something far grander? Is it possible that our universe is just a small part of an even larger structure? It might sound like pure science fiction, but now some scientists are daring to explore this idea. Every breakthrough in astronomy has pushed us further from the center, revealing a universe more vast than we ever imagined. But what if the next leap is realizing our universe is just one bubble in a much stranger, larger existence? If that's true, what lies beyond? Is it another universe or something ruled by laws we can't even begin to imagine? This concept flips our understanding of the Big Bang on its head. It might not be the origin of everything, but just the beginning of our own cosmic neighborhood. It's like a goldfish suddenly realizing there's an entire world outside its bowl. Could we ever reach out to this greater reality? Might it influence us in ways we don't yet understand? These questions, once reserved for comic books, are now being seriously considered thanks to the revolutionary data from the James Webb Space Telescope. The universe just became even more fascinating and even more mysterious. To ask these cosmic questions, we need a special tool, the James Webb Space Telescope, or JWST. Launched in 2021, JWST is a marvel of engineering, a time machine designed to look back to the dawn of the universe. It's not just an upgrade from Hubble, it's a whole new way of seeing the cosmos. Its mission to see the first stars and galaxies after the Big Bang. JWST's primary mirror is over 21 feet across, made of 18 gold-coated segments, collecting far more light than Hubble. Think of it as a giant light bucket catching ancient photons that have traveled for over 13.5 billion years. Unlike Hubble, which orbits Earth, JWST sits a million miles away at a stable point called L2, where it stays incredibly cold. Its 5-layer sun shield, the size of a tennis court, blocks heat and keeps its instruments at minus 370 degrees Fahrenheit. Why so cold? Because JWST is designed to see infrared light, essentially heat radiation. If it were warm, it would be blinded by its own glow. By staying cold and far from Earth's heat, it can detect faint signals from the most distant objects in the universe. This ability to see in infrared is what makes JWST a true cosmic time machine. It's our new window into the universe's earliest moments. JWST is a cold, giant, infrared-seeing machine. But why is infrared so important? As the universe expands, light from distant galaxies is stretched, redshifted into the infrared. Hubble can't see this deeply redshifted light, but JWST can. That's why we call JWST a time machine. It lets us see galaxies as they were when the universe was in its infancy. Hubble showed us mature galaxies, but the first galaxies remained hidden. Until now. JWST pierces the cosmic veil, revealing the era when the first stars ignited. Imagine looking at a mountain range through fog. Hubble sees the closest peaks. JWST sees the distant hidden ones. It's not just about seeing farther, it's about seeing differently. Infrared light penetrates cosmic dust, letting JWST peer into stellar nurseries where new stars and planets are forming. Hubble's visible light eyes couldn't see inside these dusty regions, but JWST's infrared vision can. It's not just a more powerful telescope, it's a whole new sense, revealing a universe we've never seen before. The cosmos is opening up in ways we never imagined. With its powerful new eyes, JWST began sending back images that were not just beautiful but deeply puzzling. It found extremely distant galaxies that were far more massive and well-structured than anyone expected. According to our theories, the first galaxies should have been small and clumpy, not fully formed, yet JWST found them almost fully grown when the universe was just a toddler. These universe breakers challenge our understanding of how galaxies and dark matter form. JWST also detected strange large-scale alignments of galaxies that defy our models. The standard model predicts matter should be distributed randomly, but JWST hints at unexpected organization. Subtle anomalies in the cosmic microwave background and the distribution of early galaxies are emerging. Are these random flukes or whispers from a time before the Big Bang? Some scientists wonder if these are imprints from a collision with another universe. The data is so new and strange, it's forcing us to consider possibilities once thought unthinkable. These puzzling discoveries have sparked both unease and excitement among NASA scientists. The data from JWST is so perplexing, it's forcing a re-evaluation of our most fundamental assumptions. The standard model of cosmology, long successful, is starting to show cracks. What if these anomalies aren't just details but signs of a much larger reality? Maybe our universe isn't isolated but part of a vast cosmic ecosystem. The idea that our universe is not alone, the multiverse, is gaining traction. Once purely theoretical, the multiverse is now being considered as JWST's data hints at physics beyond our cosmic horizon. The fear isn't about danger, but about being fundamentally wrong about everything. Imagine building a beautiful model of the universe only to find it's incomplete. But this is science, challenging our ideas in the face of new evidence. The concern is a sign that science is working, pushing us into the unknown. If our universe is part of something larger, what could that be? One idea is the bubble universe model. Our universe is just one bubble in a vast multiverse, each with different physical laws. Our Big Bang was simply the moment our bubble started to inflate. JWST's strange findings could be the result of our bubble interacting with another. String theory offers another possibility. Our universe is a three-dimensional brain floating in a higher dimensional space. Other brains, other universes could be just a tiny distance away, invisible to us. Gravity might leak into these extra dimensions, explaining its weakness. The anomalies JWST sees could be caused by the gravitational influence of another brain. Or perhaps we're part of a reality so vast and different we lack the words to describe it. The ultimate cosmic horror, our universe might be just a detail in a reality beyond our comprehension. This new era of discovery is a double-edged sword for scientists. There's incredible excitement, the chance to rewrite the textbooks and explore new mysteries. Finding evidence of a multiverse would be the greatest discovery in science. But there's also trepidation. The standard model of cosmology has explained so much, and to find it incomplete is daunting. It means we've been looking at the universe through a keyhole, missing the bigger picture. This mix of excitement and fear is the hallmark of scientific revolutions. Letting go of cherished ideas takes courage. The fear isn't of the unknown, but of unlearning what we thought was true. Ultimately, excitement outweighs fear. Science is about asking questions and seeking answers, no matter how uncomfortable. A universe that surprises us is one that invites us to keep exploring. The fear is natural, but the excitement is the engine of progress. It's the cosmic call to adventure, and scientists are ready to answer. So what do we do with this new unsettling vision of the cosmos? We look closer, we build better tools, ask sharper questions, and celebrate the mystery. The idea that our universe might be part of something larger is an invitation to curiosity, not despair. It's the cosmic perspective. We are part of a vast, interconnected story stretching back billions of years. Each discovery refines our place in the universe. Learning we might live in a multiverse would be the next great step. This perspective unites us in wonder. Science is our guide. It doesn't give all the answers, but it replaces assumptions with evidence. The story of JWST is science in action, predictions, new data, and progress. Even if the unknown is terrifying, discovery empowers us. Whether our universe is alone or one of many, it is our home. Learning more about it enriches our lives. JWS continues its silent vigil, gathering more clues. So keep looking up with curiosity, not fear.